Hello my dear students, once again welcome back for chemistry online class. Today we will begin new chapter in chemistry, that is chapter 4, atomic structure and chemical bonding. Today I would like to explain you atom, Dalton's atomic theory, modern atomic theory, and the structure of an atom. Before I start this, I would like to recapitulate that we have done in previous class. As you know that we are surrounded by many substances, and these substances are made up of matter. Now what is matter? Matter is anything that occupies space, has mass, and which can be perceived by our senses. Matter exists as three physical states: solid, liquid, and gas. All matter consists of minute particles. Minute particles means very small particles, even which we cannot see with our naked eyes. And these particles, these minute or very small particles, are called atoms. Let's move on to today's topic. First one here, atom. Now what is an atom? An atom is the smallest particle of an element that possesses all the properties of that element. Now next here, Dalton's atomic theory. John Dalton in 1808, he proposed a theory of an atom which is known as Dalton's atomic theory. According to this theory, number one, all matter is composed of atoms. Here, according to his theory, all matter consists of minute particles, and he called these minute particles as atoms. Number two, all atoms of the same element are identical in all respect. That means all atoms of same element have same physical and chemical properties. Number three, atoms of different element are different. Now number four here, atoms unite definite ratio to form compounds. According to this theory, atoms, when they are chemically combined in a fixed ratio, they form a compound. Now next, number five, atoms can neither be created or destroyed. According to his theory, we cannot create atom or we cannot destroy atom. Or it means that atoms are indivisible, further they cannot be divided. Now next show, modern atomic theory. According to modern atomic theory, atoms are divisible into subatomic particles. Now here what Dalton's atomic theory state that atoms are indivisible, further they cannot be divided. But according to modern atomic theory, atoms are divisible into subatomic particles: electrons, protons, and neutrons. That means an atom consists of subatomic particles: electrons, protons, and neutrons. Number two here, atoms of the same element may not be alike in all respect, as in the case of isotopes. Isotopes are the atoms of the same element having same atomic number but different mass number. Here, John Dalton said atoms of the same element are identical in all respect, but according to modern atomic theory, atoms of the same element may not be alike in all respect, as in the case of isotopes. Now next here, structure of an atom. For this, I'll take an example of sodium. Now atomic number of sodium is 11. It means atomic number means is the equal number of electrons or protons present in an atom, or equal number of positive and negative charged particles present in an atom. Here atomic number of sodium is 11. It means that sodium atom has 11 electrons or 11 negative charge. 11 electrons. Protons. An atom is electrically neutral because an atom has equal number of positive and negative charged particles. See, 11 electrons and 11 protons, or 11 negative charged particles and 11 positive charged particles. I'll write your particles. Sorry, I'll write your particles. Charged particles. P-A-R-T, particles, charged particle, 11. Now, mass number is sum of the protons and neutrons present in an atom. Mass number means sum of the protons and neutrons present in the nucleus of an atom. Nucleus is the central part of an atom. Its mass number is 23. Now, how to find out the number of neutrons? When you subtract the atomic number or number of electrons or protons from mass number, you will get neutrons. Neutrons. Here, neutrons, 23 minus 11 is 12. Now, this atomic number of an atom is very important because it gives an electronic configuration of an atom. Electronic configuration of an atom is the distribution or arrangement of electrons to the respective cells, which is followed by the rule 2n square. First cell accommodates only 2 electrons, second cell 8, third cell 18, fourth cell 32, and so on. Here the atomic number of sodium is 11. So its electronic configuration is 2, 8, 1. Now here I will draw the orbital structure of sodium. Here nucleus is the central part of an atom. It contains protons and neutrons. Protons 11 protons, and neutrons 12 neutrons. First cell, how many electrons are there in the first cell? 2. I'll write here. Now next, second cell, 8 electrons. 2, 4, 6, 8. Now outermost cell has 1 electron. Here, nucleus is the central part of an atom. Nucleus is the central part of an atom. N-U-C-L-E-U-S, nucleus. These are electrons. Electrons are the negatively charged particles of an atom. Electrons. Here, these are the orbit or the cells. Orbit or the cells means imaginary part of an atom where we find electrons, and these electrons, they revolve around the nucleus. This is cells and or orbit. Cells or orbit are the imaginary part of an atom where we find electrons, and these electrons, they revolve around the nucleus. You know, nucleus is the central part of an atom. As you can see here, the orbital structure of what? Sodium atom. Once again, I will repeat here. Atomic number of sodium is 11. Atomic number means equal number of electrons or protons present in an atom. Atomic number of sodium is 11. It means that sodium atom has 11 electrons and 11 protons, or 11 negative charged particle or 11 positive charged particle. Here, mass number means sum of the protons and neutrons present in the nucleus of an atom. Mass number of sodium is 23. As you can see here, 1 plus 2, 3, 1 plus 1, 2, 23, 11 protons and 12 neutrons. So the mass number of sodium is 23. How can we find out the number of the neutrons? When we subtract the atomic number from mass number, or when we subtract number of protons or electrons from mass number, we will get neutrons. See, 23 minus 11 is 12, 12 neutrons. As you can see here, nucleus is the central part of an atom. And here electrons, they are found in the orbit of the cells. And this orbit or the cells, these are the imaginary part of an atom. And here this atomic number is very, very important because it gives the electronic configuration of an atom. Electronic configuration of an atom means is the arrangement of electrons or distribution of electrons to the respective cell, which is followed by certain rules. By rule 2n square. First cell accommodated only 2 electrons, second cell 8, third cell 18, fourth cell 32 and so on. Dear children, here we have come to the end of today's online class. Thank you very much.